Alright, this was a quiz on Venn diagrams, set notation, and probability. So, problem number 1. Create a Venn diagram for the following scenario. Of the 360 seniors at Matthews High School, 220 take math, M, 172 take science, that'll be event S, and 139 are taking both math and science. Don't forget to label your circles. Okay, so we're making a Venn diagram, so we'll probably draw some circles in here to show the sets. So this will be one of my sets. Okay, it usually starts off white. Okay, I think I'll make it a different color though, just for fun. Alright, so there's one of my sets, and so I'll let this be the set of students taking math. So I'll go ahead and label that with an M. Okay, so now we'll need another circle to represent students that are taking science. Let's see, let me make them overlap nicely. So I'll put an S on this one because this is the set of science students. Okay. Alright, now it says that 220 students take math, 172 take science, and 139 are taking both. You always want to start with the overlapping part of the Venn diagram and see what's going on there. So, of course, the overlapping part is the group that's taking both. Alright, so that's 139. So, 139 students will be in this part of the diagram. Now, the common mistake that students will make is to put the entire number for whichever set it is right here. So 220 students take math. So if I put 220 right here, that would be the common mistake. Alright? Because the problem, of course, is this 139 also represents students that are taking math. So by putting both of those numbers in the same circle, and let me just temporarily delete this to make it really obvious, I'm saying that 220 plus 139 students are all taking math. But these two numbers should add up to 220. So in other words, what I need to do is subtract. I need to do, and you know what, I'll just make this a small calculator today. Okay, I need to do 220 minus 139. Okay, so that leaves 81 students to be in the outward part of the circle. Okay, because this number represents students that are taking math only. Alright, a total 81 plus 139, a total of 220 students are taking math. Alright, 81 of them are taking math but not science. 139 of them are taking math and science. But if you add these two numbers together, that's the 220 that they're talking about. Okay, so hopefully you understand why you can't just put 220 over here. Alright, the total of all the math students, which include this number and this number, have to add up to 220. So similarly for the science, if there are 172 students taking science, I cannot put 172 in this part of the diagram because this number, the 139, and the number of students who are taking science only have to add up to 172. So again, the operation I need to do is I need to take the total number of science students and subtract the number that are also taking math. Alright, subtract that overlapping number. So that tells me that I have 33 students that are taking science only. And that's the number that goes out here, the science only people. Alright, but these two numbers should add up to 172. Okay, now you may notice another problem. If I add up these numbers, these three numbers, okay, let's see what we get. So if I do 81 plus 139, whoops, that's not the plus key. Oh, I guess I got to start over. 81 plus 139 plus 33, that's only 253. And it said there are 360 seniors at this high school that we're supposed to be working with here. So that means there must be some students that didn't take math or science. So there must be a number that we'll have to put out here outside of the math and science circles to represent the extra students to add up to 360. So once again, I'll have to subtract 360 minus the 253. Alright, that tells me that there are 107 students who aren't taking math or science. Alright, 107 seniors anyway. Okay, so let's see, I'll use a third color for that, just a random other color. Alright, so 107 students are not taking any math or science. So that completes the Venn diagram. Pretty tricky. If hopefully you understand now that I broke it down for you. Okay, let's go on to problem number 2. Suppose a survey was conducted among the students in a classroom to find out if they have a pet, and if they do, whether it was a dog or a cat. Alright, out of the 30 students questioned, 18 had dogs, 15 had cats. However, 5 students have both a dog and a cat. Alright, so we're supposed to state how many students are in each subset below. Now, during this quiz, I had several students questioning and going, it says 18, but then it says only 13 right here. And I felt bad because, you know, I can't help a student during a quiz. But I'm hoping that it can be very easy for you to see that, you know, the number of students that had a dog are, you know, includes both of these numbers. Okay, some students have a dog and a cat as well, but in terms of how many students, you know, the 18 students that have dogs, just because you also have a cat doesn't mean you don't have a dog. Okay, so of the 18 students that have dogs, 13 students have just only a dog, and 5 students have a dog and also a cat. But total 13 plus 5, total of 18 students have a dog, so there's nothing wrong with that. Similarly, when it says 15 students have a cat, that doesn't mean that 15 students have only a cat. All right, that's not what it says. It doesn't say 15 had only a cat. It said 15 have cats. So of the 15 that had cats, according to the diagram, 10 of them had only a cat, and 5 of them had a cat and a dog. All right, so there's nothing wrong with this. These two numbers have to add up to 15. Okay, and so this 2 means that there were 2 students that didn't have a cat or dog. Okay, So now let's find these subsets. So this intersection means and, okay? This means and. So this means we're looking for the number of students that have a dog and a cat, all right? The overlapping part. So that's going to be this right here. So the answer there is going to be 5. Okay, now this union symbol means or. So ignoring the complement symbol for a moment, all right, the union of dog owners and cat owners means all of both. Okay, all of both sets will be the union, right? All the dog owners plus all the cat owners. So visually, if I were to start highlighting, I would be highlighting this whole situation. Okay? Okay, it went a little outside the lines here, but you can see I'm shading the union of dog and cat would be the 13 and the 5 and the 10. But then we have this complement symbol, okay? And of course, this little complement symbol here takes the whole set that we just shaded and it puts a big not on it. All right? Not the union of dog and cat. Not everything that we just shaded. So what's the number that represents the people that do not have a dog or a cat? And that's this number right here. Okay, this white area is the not union part. So that's 2. All right, now how many students have a cat only? Yeah, that's the 10. All right, they have a cat but not also a dog. So that's just 10. Okay. Now probability. You can tell this is probability because of the P. So this means find the probability of randomly picking a student who has a dog. And so some students were wanting to assume that that meant dog only, but no. All right? Probability of having a dog, means probability of having a dog regardless of whether or not you have a cat. So don't assume it means dog only. It just means dog. That's it. So probability is target over total. I'll just put it right here and refer back to it. All right, the probability of any event is always going to equal the target outcomes divided by the total number of possible outcomes. Okay, in this case, our target outcomes are people who have a dog. So when I do target over total, I'm going to do dog owners divided by all the people in the survey or the class or whatever it was. So looking back at the circle, all the dog owners, there were 18. And of course, we can get that back from the question, 18 dogs. And the universe, right here, it says there are 30 students in the survey. So that's going to be 18 out of 30. Okay, if I want to leave that as a fraction, I need to reduce. Both of these are divisible by 6. So I can do this mentally. If I divide both of these by 6, that's going to be 3 over 5. Okay, or you can use your calculator if you can't handle the truth. Okay, so I have 18 divided by 30, and it reduces it for you. If I toggle it, I can get the decimal, which is 0.6. And I could rewrite that as a percent by moving the decimal twice. That would be the same thing as 60%. So either of these forms are acceptable. Okay. Now for E here. The intersection. All right. So the intersection of dog and cat. All right. Again with the and. All right. These are the people that own a dog and a cat. So target over total. Okay, I know the total will still be 30 because that's the total number of students. So let's look back and remind ourselves how many people had a dog and a cat. 5. Okay, so that's going to be 5 out of 30. That reduces down to 1/6 if I divide both of these by 5. Okay, as a decimal, is 0.1667. Got to round up. Which would translate into 16.67%. So these are the 3 ways that we express the probability. Number 3, 60 British students each visited one foreign country last week. Out of the 60 students, 75% are female, 40% of the students have visited France. There are 33% of the students who are female and have visited France. So, okay, female visited France. Are the events being female and has visited France mutually exclusive or overlapping? Explain. Okay, well, if there's any overlap, it'll be overlapping. This sounds silly, but it's just that easy. If there are female students who visited France, then it'll be overlapping because they have something in common. The two groups have people outcomes in common. So, it says there are 33% of students who are female and have visited France. That means it is overlapping. Okay, yeah, overlapping because there are students who are female and have visited France. If a student is randomly selected, find the probability that a student is female or has visited France. Well, guys, this is an overlapping situation like we just decided. So this would be a perfect time to use the probability formula that says if you want the probability of A or B, if these events were mutually exclusive, all right, if there was no overlap, we could find it by just doing the probability of A individually and the probability of B individually and just adding those two together, and that would be the probability of A or B. But when they're overlapping like this, we have to do one additional step, and we have to subtract the overlapping part. All right, because if you take the one event, and then if you take the other event, it should be like this. If you just add them together, the problem is you're adding this middle part twice. All right, you're including it once with the blue circle, but then you're including it a second time with the pink circle. So this is our way of subtracting out the overlapping part because it's repeated accidentally. So we have to subtract the intersection, subtract the probability of A and B, the overlapping part. So for this problem, this is definitely the quickest and easiest way to do it, because we can find all of these things very easily. Okay, they gave us the percentages, so that means out of 100, it automatically means out of 100. It automatically is the probability when they're giving you a percent. So instead of A and B, here's what we have. Actually, I changed my mind. We're going to stick with A and B. We'll let event A be being female, and we'll let has visited France, we'll call that event B. So the probability of being female, well, it said 75% are female, so that's the probability of being female is 75%. Okay, the probability of visiting France, they said 40% of the students have visited France, so that's the probability right there, is 40%. Okay, and then the probability that both are happening at the same time, that's the number they gave us in the third sentence. There are 33% of the students who are female and have visited France, so that's the 33%. Okay, so that's all you do. You add these two numbers and then subtract. So let's see. So 75 plus 40 minus 33. So that's 82%. Okay, that's all there is to it. That's how you have find the probability that a student is female or has visited France. Alright, now I'm going to do that problem again the long way, which would be to do a Venn diagram. Alright, so let's put in the information. I'm going to let the yellow circle here represent the percentage of students that are female. And I'm going to let the blue circle, well, I guess I have to use the whole word, don't I? Because female in France start with the same letter. Alright, so I'm going to let this circle be the percentage of students who have been to France. Okay, so female in France. Obviously, this portion will be the percentage of students who are both female and have been to France. So let's put in the numbers. Always start with the overlapping part. So we know 33% of the students are female and went to France. We know that 75% of the students are female, but now we know better. We know not to just put 75% right here, all right? Because this 75% is partially made up of the 33%. So we have to subtract the 33%. All right, so you see that 75 minus 33 is 42%. So that means that we'll have to say 42% will go right here, because these are the students who are just female but have not been to France. So if you add these numbers up, you get the 75% mentioned. Now let's do the same thing with students who have been to France. We know that there's a total of 40% of students who visited France. So if 33% of those are female, that means 7% are not female. Okay, so these are the numbers. Now, just for fun, I don't think we need it to solve the problem, but it would be interesting to know, are these all the students, or are there some extra students? So let's add up all three of these numbers. Well, 33 plus the 7, that's your 40%. But so that means we have 40% plus 42%. All right, so that's 82%. Okay, so we did need to do that anyway. Okay, so we might as well write that down, because we're trying to find the probability that a student is female or has been to France. In other words, we're trying to find the percent of this whole union All right, everything that's colored in, the yellow, the green, and the blue. So we just added that up and found out that that was a total of 82%. Okay, so that is the same thing that we got when we used the formula. Okay, so this was another way to find the union of those two events. So, but notice, if that's 82%, then that means that there were 18% of the students in the outside zone. 18% who are not female and have not been to France. Okay, but of course the 82%, that was the answer. Alright, here's the last problem. Two number cubes are rolled and their sum is calculated in the following table. Find the following probability. So first of all, glancing at this table over here, understand that these numbers represent, if you look at the 1, 2, 3, 4, 5, 6, these would be the outcomes of rolling one number cube. Alright, maybe it's a 1, a 2, a 3, a 4, a 5, or a 6. The numbers across the top here represent the possible outcomes of the other number cube. 1, 2, 3, 4, 5, or 6. So let's say if I rolled a 3 on, whoa, that's unfortunate. Let's say if I rolled a 3 on one number cube and a 4 on another number cube. Well, look, the sum would then be 7. And you can see that by the column and row. So that's what they've done to populate this entire table. 4 plus 1 is 5. 5 plus 2 is 7, and so on. So these bold numbers are all sums representing the two numbers that you get if you rolled two number cubes and then added them together. So we can use these numbers to answer the question. Alright, so we're going to find the probability that the sum is less than 4. And just in case you had forgotten that this was a less than sign, I wrote it out for you in words. The probability that the sum is less than 4. Okay, so look at these sums and look for the ones that are less than 4. They are here, here, and stop doing that, here. Alright, there are 3 outcomes that are less than 4. 3 events, I guess I should say. Okay, so whenever we do probability, you know the probability of any event, well, maybe I should just stick with the probability that the sum is less than 4. We start by thinking target over total. Okay, and we just saw that our target, there are 3 of them. Alright, there are 3 outcomes that we're shooting for. Alright, so that's the target, sums less than 4. Now the total is going to be the total number of outcomes on this chart. Well, this chart is a 6 by 6 chart, so we know that 6 times 6 is 36. So target over total is 3 out of 36 outcomes. And if we want to leave this as a fraction, we have to reduce it. So this is going to be 1 over 12. But if you wanted to, you could put it as a decimal, 0.0833. And you must use 4 decimal places if you're going to do that. But we could also write it as a percent by moving the decimal point twice. That gives us 8.33%. Alright, so these are the 3 ways that you could display your probability. So notice that one of those ways is a percent. So like when we looked at the other problem where they gave us percents, if they're giving you percentages, that's why it's automatically the probability. All right, that's why we get probability as a percent. Anyway, that was the answer to part A. Now let's find the probability that the sum equals 6 or 9. All right, well, let's just look at how many of those there are. All right, so these are the ones that equal 6, and these are the ones that equal 9. All right, 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, there are 9 outcomes like that. So once again, target over total, that's 9 out of 36, which is 1 out of 4, dividing these both by 9, which we know to be 0.25 or 25%. All right, so that's part B. Now, what's the probability that the sum is odd or less than 4? Okay, looking back at the table, all right, so let's start with the less than 4 part. Now let's do the odd part. All right, never mind that we picked up a couple odds when we did the less than 4 part. That's okay, as long as they are highlighted. All right, these are all the numbers that are either odd or less than 4. So how many do we have? Well, when we did the odds, we were getting half the numbers. So I'm trying to avoid counting them all up. So the way I could do that is realize when I did the odds, I was getting half the numbers. So half of 36 is 18. But I'm also picked up one additional number because the 2. I picked that up because it was less than 4. So that'll make 19. So there are 19 outcomes of the type that we are shooting for. So target over total in this case will be 19 out of 36. All right, and we could express that as a decimal. So that's 0.5278. Got to round up. All right, always use 4 decimal places if you write your probability as a decimal. Or you could turn it into a percent, which would be 52.78%. All right, and that's the answer to part C, and that was the last problem on this quiz. I hope this video helped you to understand, and I will see you on the next video.